Okay, so the first video on the equator function we ended at finding the determinant of this matrix, and we have already broke it down. So we can now go ahead for 2 by 2. If you are not okay or good with finding the determinant, you can still watch the video on the determinant of matrix. So here we see the application of matrix in microeconomic theory, a matrix that is learned at senior high school level, appearing in tertiary level, and this one the microeconomic theory is master's level. So matrix in master's level, normal matrix determinant. So I have my F11, then this multiply this according to the determinant for 2 by 2, this multiply this minus this times this. So I have 0 minus this times this is positive, so I have F2, but it should be F2 squared because these are the same. It's like x times x, you have x squared. So minus F1, 2. This times this gives me 0. I also have minus, so minus F1, F2. Another minus F1. This time this gives me minus F2, F21. Minus, so plus F1, F22. So it seems this thing is descending the mountain. So F11 times 0 gives me 0. Then F11 times negative F2 squared gives me negative F11 F2 squared. Then this negative times this gives me 0. This time this gives me equals to half plus F1, F12, F1, F2. Then this time this gives me positive, so I have plus F1, F2, F21. Then this will give me negative, so I have negative F22. F1 will give me F1 squared. So if we actually equate it to 0, so I'll say 0 is equal to 0 is equal to. Now, this is where we have to apply the Young's theory. We have F1, 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 F1 to F21. But according to Young's theory, F12 is the same as F21. So this will be like you have X, Y, A, and then you have plus X, Y. If they are the same, let me write even B. If I say A is equal to B, that means that I have 2X, Y. I can either use A or I can use what? B, since they are the same. So with this one, we can try and use the 2-1 or 2-2. So we have minus F11 F2 squared plus 2 F1 F2. Then we can use F12 or F21, however you want to write it. Minus F22 F1 squared. This is what we call the Quasi function, but I want to get rid of the negative, so I can write it as, when I want to get rid of the negative, I can bring everything to this side, or I will say multiply 3 by negative, any of them, so that I will get, F11 F2 squared minus 2 F1 F2 F12 plus F22 F1 squared equal to 0. So we have proved the Quasi function. So now for concavity and for convexity, when you have a graph like this is concave, this is convex. So for concavity, it is believed that everything should be less than 0. So for quasi concavity, F11 F2 squared minus F should be less than 0. So quasi concavity. So quasi concavity. And for convexity, f1 f2 squared minus 2f1 f2 f1 2 plus f2 to f1 squared should be greater than 0. That becomes the quasi convexity. But we have to explain how can we get, if I have this, how can this become less than 0? How can it become greater than 0? It depends on the values we have here. This depends on this value. This one, and these two values. This is positive. If this is negative because of the square, it will still end up being positive. If this is also negative because of the square, it will still end up being positive. So, but if this is negative and this is negative, this and this will be negative. With this being negative, I'll have this being equal to positive. It will nullify this negative to be positive. So it means that I have my negative being greater than the positive values. When they rule out, if the negative is more than the positive, I'll end up getting less than 0. So that's when you can talk about the concavity. For it to be convex, then the positives should be greater than the negatives. So it depends. And we quoted that f1, f this should be their conditions. F1 and f2 should be less than 0. So you look at it. When this is negative, this is positive, how will it give? So you look at that one, then you apply some normal algebraic thoughts to convince the examiner that with this you get a concave, with this you get a convex. So that's the quasi concavity, quasi convexity.